Find two possible geometric sequences where the sum of the first two terms is 9 and the sum of the first four terms is 45, and write down the general term of each sequence. So if the sum of the first two terms is 9, that means that means S2 is equal to 9. If S2 is equal to 9, using the formula, that is U1 times R squared minus 1 divided by R minus 1. And if S4 is equal to 45 from the formula, that is U1 times R to the 4 minus 1 divided by R minus 1. Now we have two equations in U1 and R in two unknowns, so these are simultaneous equations. They're not linear simultaneous equations, there's a bit of work we need to do to solve these. First of all, I'm going to start with the left-hand side, and we're going to manipulate this a little bit, and then we'll come back and manipulate this one a little bit. So first of all, I notice that R squared minus 1 is a difference of two squares. So I can write it as R minus 1, R plus 1. And then I have a common factor of R minus 1 on the top and bottom. So I can simplify this down to 9 equals U1 times R plus 1. Now on the right hand side, I'm going to do a similar thing. I have 45 equals U1, and R to the 4 minus 1 is also a difference of two squares. It's R squared minus 1 times R squared plus 1 all over R minus 1. But then I have a difference of two squares here again. So I can factorize that difference of two squares again. R squared minus 1 becomes R minus 1, R plus 1 times R squared plus 1 all over R minus 1. Again, I can cancel the R minus 1's. So I get 45 equals U1 R plus 1 times R squared plus 1. But now notice that this here, U1 times R plus 1, is what I had here in blue. So I can replace that whole UR times R plus 1 with 9. So 45 is equal to 9 R squared plus 1. Divide both sides by 9. I get 5 is equal to R squared plus 1. Which means that R squared is equal to 4 and R is equal to plus or minus 2. Now that I know that R is equal to plus or minus 2, I can find the possible values of U1. The easiest way to do that is using this formula here, which connects U1 and R. So I can substitute in when R is equal to 2, 9 is equal to U1 times 2 plus 1 is 3. So U1 is equal to 3. When R is equal to negative 2, we have 9 is equal to U1 times negative 2 plus 1 is negative 1. So U1 is equal to negative 9. So this gives me two different formulae for geometric series. I can either have UN is equal to 3 times 2 to the n minus 1, or UN is equal to minus 9 times negative 2 to the power of n minus 1. To show where these come from, the 3 comes from this 3 here, and the 2 comes from the positive 2, and And then minus 9 comes from the minus 9 here. And the minus 2 comes from the minus 2 there.